Good afternoon, everyone. My name is Will. I'm one of the co-founders of Coactive AI. This is I think I'm the first speaker for the open mic session, so thank you all for coming. Okay, can you guys hear me now? Is that better? Okay, awesome. Okay, all right, let me know if I'm not speaking loud enough first, please. Hey, so everyone, my name is Will Gaviria. I'm one of the co-founders of Coactive AI. Today, I just want to tell you a little bit about some of the lessons that we've learned. We're building data plus AI systems at Coactive. Thank you all. If you want to connect with me, I'm going to be hanging out here, so we'll love to just chat. All right, so one of the things I want to start off is just talking about data. One of the things that we see is that data has just been evolving over time. Overall, we're going from, 10 years ago, we thought of data just being these tables. Now, and more, we're thinking about being content, right? It is text, it is images, it is video, it is a combination of all of these. So data is changing, right? And so have the tools that we have to make sense with them. And that's where AI really comes in. So to kind of quote Bill Gates, right? He said, content is king. And if content is the king is already here, right? 80% of unstructured, or 80% of data is already unstructured. It's going to be unstructured by 2025. I think really the important thing is regenerative AI. We actually are about to get an explosion of unstructured content because it's going to be so easy to just make a lot of this content. And so we're just going to generate a lot of it over the coming years. And we have to make sense of it. And so that's where AI really comes in. So that's truly the data plus AI. Data is essentially the bread of all of this, and AI is going to be what we're going to need to use to make sense. So what's the point though, right? Like if content is the king, and AI is the queen, right? It's a royal marriage. It's actually not very easy. So this is what the stack looks like today for a lot of folks. You have a lot of data being generated. Some of it's structured, some of it's semi-structured, some of it is unstructured. For the structured and semi-structured data, there is a playbook that already exists, right? I mean, there's a lot of work that we did to get there, but you can kind of make sense of it. For unstructured data, though, it's a little bit of a mess. We store it, we archive it in blob store, and we don't do a whole lot with it afterwards, or at least most companies don't. And so what I want to talk about today is, what happens after we capture all this unstructured content? And that's where it gets pretty hard. A lot of folks have a lot of difficulty doing stuff, so they actually end up doing nothing. That's the easiest path. A lot of folks hire human labelers. That's what happens a lot with images. A lot of folks have AI-powered APIs. That's where a lot of us are here today, frankly, right? But I want to talk about moving towards reliable, scalable, adaptable data systems that are AI powered, and that's actually what we've been building on at Coactive for the 3+ years. And there's a few lessons that we learned along the way that I just want to share with you because I know a lot of folks are in the do-nothing stage and they're getting started, and so I just don't want you all to make the same mistakes that we see over and over again from everybody in the field. The first thing, I just want to set the tone. Despite everything that happens in the Twitterverse and what you see folks talking about, the reality is that most enterprises are just not doing AI, right? AI adoption is growing rapidly, but most folks still aren't using it. So if we are building tools today for these folks, we have to empathize where they're at and meet them at this stage, right? They're just getting started with AI. How do we build these data systems for them? And I think that's a key part of just empathizing again with the customer and something to keep in mind as we build these tools for them. The other two lessons I want to go over, though, are actually key if you're one of these folks who are designing these data systems. So the first lesson is logical data models matter a lot more than you think. I'm going to go over these slides mostly as a visual reference, but feel free to just ping me afterwards if you want the slides. I'm just going to go through them a little bit fast, but really the key is this. A lot of folks see AI as this kind of monolith that sees between the data that comes out of the model that people use and the data that sits in some sort of blob store, like a key value store most of the time. And the pitfall that a lot of people have is that there's a clear owner of the blob store, the data engineering team typically. There's a clear owner of these foundation models that people leverage, like the AI team, the ML team. But this handoff is often overlooked. And what ends up happening is that this is actually a huge technical depth in disguise. Because when we store these things, we think about them from a standpoint of a key value store, right? Some JSON and there's some bits and bytes assigned to it. But it turns out that this AI models actually have a lot of specificity. It is data specific, right? Is it text? Is it audio? Is it image? Is it video? It is also task specific. Are you doing object detection? Are you doing sentiment analysis? Are you doing captioning? And this combinatorics of the two actually leads to quite a lot of variety in the logical data model of the inputs for these AI models. So what do we see happening time and time again? No one actually owns this impedance mismatch the data team builds something that doesn't really work for the AI team. The AI team builds something bespoke that doesn't really scale. And the end result is that all your AI solutions are ultimately bottlenecked and no one knows why. I just want to go a little bit more in depth into this, into the technical depth that happens if you don't think about it. Because if you have some piece of unstructured text like this, and it's going into, say, some summarization task, that, maybe you don't need a transform, and this is a really simple impedance mismatch. There is no mismatch. You just feed what's in the key value store into the AI models. But if you have something slightly more complicated, like a language detection task or a sentiment analysis task, you may need to do some transformation. You may need to do some key face extraction. But the whole point is that what goes into the AI model no longer looks like what's stored. And actually capturing this transformation is super key in unlocking the next level of quite frankly, scale. Because what we see success is folks that then think deeply about this. They get together with the data folks and the AI team. They build a hybrid team. They build a lot of impedance mismatch transforms. They build a lot of different logical data models. And then all of a sudden, your solutions actually can perform pretty well and can scale. Not only does this end up resolving the AI bottleneck, but you also get a lot of pathways for optimization. One of the things I want to talk about is for image pre-processing, where we saw this, is I'll give you, this is a real example of something we saw happening where you have over here 3 AI researchers are feeding images into the PyTorch models. They're all fetching the same thing from the key value store at image. They're then doing the same transform, and then they're using these images and feeding them to their models. But if you see this is insane because they're all doing the exact same compute, the exact same I/O 3 times. So if you think about this, a very simple model is simply fetch it once, transform it once, serve the smaller transform image, and then what you end up doing is you reduce compute, you reduce I/O, and you actually get higher GPU efficiency because you're spending less time on I/O and doing this computation that is frankly not valuable from the standpoint of AI. So this is just one example of many examples. Another thing I wish I had more time to talk about is you can actually leverage a lot of the outputs from these foundation models to cache compute, right? Unfortunately, I don't have time enough to talk about this today, but come see me. We'll love to chat some more. We have an awesome follow-up talk from Sam from Redis, who's going to talk a little bit more about this. So big shout out. And then some parting thoughts. I think for a lot of us that are building these tools now, I think the ones that are really going to capture the opportunity are those that build tools that actually scale. Data, pipelines, and infrastructure, it seems kind of boring, but this stuff actually really matters. So if you find yourself planning for something like this, but your solution actually ends up looking something like this that just feels really finicky and feels really fragile, then you might want to take a look at your foundation of what you're doing even before you get to the AI part. I just want to quote one of my buddies, Joe Reese, who said it really well, because I do want to empathize where you folks are building this, because sometimes we're just given an impossible task, because the reality is a lot of this data is really in shambles, right, at the enterprise level. So expecting to stick LLMs on top of an infrastructure that's not there to support it, it's just a very difficult problem. So just encourage you all to, talk to your fellow data engineers, talk to your fellow AI, get together in the same room, and you can actually solve a lot of these problems and build AI solutions at scale. The importance of scale, though, I just want to give an illustration, is that, we're moving from data lakes to oceans, right? If you think about it, for a tabular data source, let's say you have a bunch of numbers, and you have 10 million rows, that's going to be about 40 megabytes, right? Just to give an illustration, let's say that's the size of Lake Tahoe, right? When you switch from, say, float 32s to text, you're going to make a huge order of magnitude jump. You're now not in 40 megabytes, right? You're in 40 gigabytes. And now you're gone from Lake Tahoe to something like the Caspian Sea, which is the largest lake in the world. The second you go from text to images, this gets even worse. And you're now talking about the terabyte regime. And it's like you're trying to cross the Pacific Ocean on this canoe you made for Lake Tahoe. So that's really what we need to build these tools that truly actually capture the I/O. We're seeing some of the challenges of building these things today due to memory footprint limitation in RAM and GPU for text. But the second we go to images and video, I/O, network, latency, all these things, even disk space becomes a huge limiting factor. So again, I just want to just motivate that, scale matters a lot. Logical data models matter quite a bit. And if you're interested in this, this is what we do at Coactive. We work on these large AI problems at scale for images and video. We're looking for folks to join. If you're also thinking about tackling image and video data, we think we have one of the best class solutions. So we'd love to connect. We'd love to chat with you. Just come find me. My name is Will. Thank you all for your time.